The first thing which you should know about is I'm pretty sure you all must have gone through typical designing training in software or NX or ProE. When you are given a training, you will be taught about how to use the tools, how to use the sketches, how to use the surfacing options, solid options, and assembly options, and things like that. But those skill sets of using tools may not be useful unless you know how to apply them, on what basis you will be applying them wherever you will be working on, be it automotive or machine design or tool design or aerospace or anything of that sort. Today we'll be talking about those things, like when you need to design some parts, you need to understand the background of it, like what are the guidelines which are prescribed by company and suppliers, what are the surrounding parts which comes into picture, and what are the manufacturing aspects you need to consider, and how all these guidelines, inputs, the requirements will be captured into a product. So that is what is called as a knowledge-based engineering. In short, it is an intelligent method in engineering design, an advanced system that enables the manufacturers to capture, reuse, and leverage the knowledge accumulated in the people and processes that make the product. Incorporates critical non-geometric logic in the product development process and linked with 3D CAD system to automate the design process. So for example, it will consist of best practices, it will consist of prescribed sections, it will consist of the criteria for design for Six Sigma, commonization strategy, and supplier requirements. So this is about overview. So as I told you, it's about methodology for capturing life cycle intent about an object, including operational, functional, performance concerns, and in addition to capturing its parametric geometric variation. You all must be aware of the whole product life cycle, how it goes. Start from the styling theme and approval of conceptual A surfaces, which is called CAS, and preliminary design, preliminary analysis, final style approval, detailed design, verification, then development, then prototype build, design validation, pilot production, launch, and mass production. During this whole process of life cycle management, the design goes through several iterations. Our design should capture all the guidelines. So also it should accommodate the changes which are happening throughout the life cycle, product life cycle, and the iteration should happen very quick, in no time, and with minimized errors, so that the time can be minimized and the supervision can be minimized. So this is in short what all about the knowledge-based engineering. So it's knowledge-based engineering is a general technique which is used across various organizations in automotive industry, in aerospace industry, in tooling industry as well. So it can be used in NX as well as in CATIA. Mainly, the KBE is chartered to standardize and automate the product creation work process by developing standard operating procedures, design guidelines, and methodology, developing system-level knowledge-driven tools, including parametric CATIA V5 templates and application workbenches, deploying tools in the most efficient manner throughout the organization. So as I told you, so this is a typical way how the knowledge-based engineering takes place. So what happens, various cross-functional teams like advanced concept engineering studio, COE, CAE, EMD platform, there will be numerous teams working together in any organization. So each team will have different guidelines which each one has to adhere to while designing the parts, and that has to be formulated in the form of a standard operating procedure, design guidelines, and methodologies. These procedures, guidelines, and methodologies will be considered while creating each parametric model. So I'll be taking up with an example what I'm trying to say about. So this is all about the theoretical aspect of the knowledge-based engineering. I'll be taking up with a live example on a bumper parts, bumper assembly, how these knowledge-based engineering is applied on it. So as you can see, all these knowledge gathering is used to make a tool development. So you can see then the tool is developed, like we create a templates, and then template becomes the whole product. So if you see here, it's a combination of vehicle exteriors, interiors, seats, BIW, closures, doors, roof. So every segment of the vehicle is developed by individual teams, and individual teams will have their own design standard operating procedures, design guidelines, and methodologies. So for example, if I'm talking about, say, a bumper, so bumper will have an interface with the headlamp, with the hood, with the fender, with the wheels. For example, if I'm designing a bumper skin, I need to have certain clearances with the tire. So I will be creating the template in such a way that as and when the wheel location, if it gets changed, bumper geometry will get updated on its own. And also I will be taking references from the fender. So this is called a fender, and this is called a hood, and this is called a headlamp. So there are certain guidelines, like what should be the gap between the part, and how the interface strategy should be, what kind of attachments are used between the parts. All those things will be formulated in the form of the design guidelines and methodologies, and then the template is created. So when we go for complete training on knowledge-based engineering, there will be different modules. So I'll be taking like what kind of attachments are used, how the attachments are created using the knowledge-based engineering, how the part gets modified when the headlamp is changed. All those things will be taken into consideration at the time of detailed training, but this is what I am talking about. If you see the fascia itself, there will be several engineers working on the fascia. So it will not be a single engineer working on the fascia. So each engineer has to cordially work with each other and share their CAD geometry to a master file, and then it will be clubbed together, and then the part is completed. So for example, on a bumper, if I take a bumper, so I'll take you to the detailed explanation with another image in next coming slides. So this is what the knowledge gathering tool development application is all concerned about as far as KBE process is concerned. So besides adding value by automating design process, KBE offers other benefits, including capturing human expertise. As I told you, several people working together, single system. So there has to be some kind of a cordial coordination between all the people working together on different parts, because each parts have relationship interfaces with each other parts. So the process is continuously the learning and solving complex engineering problems. So then the detailed design phase will come. So since the conceptualization phase itself, the KBE process starts. So let me take you some of the examples in coming. So this is a typical comparison between the KBE approach and traditional approach. So in all your training courses, wherever you have learned how to design the parts using the tools and the softwares, you must have been taught about using the sketches, surface parameters, creating the solids, like how you create the part, considering a single part, which may not be sufficient enough to complete a whole vehicle design. So in traditional approach, that is what happens. So if I'm designing a part, I will just look at my part, I will design it. And like me, if there are 10 other people who are designing different parts, they will just go on designing the different parts. And a person who is taking all those parts and clubbing together and trying to find out the errors and getting changed from each and every one to solve all those problems. It's a traditional approach. What KBE approach is, like what I explained it to you. So what happens in KBE approach is you will be investing more time initially to create the templates, and then very little time in as you go on further in product development life cycle. So what happens, routine, if you take 80% of the time in creating the templates in traditional approach, for creativity, for example, if you want to do some improvements in your product design, like you want to add some creative thinkings, like some weight saving ideas, or if you come up with some intelligent solutions, all those things you will get very little time to implement on any design if you go on a traditional approach. But in KBE approach, so the routine itself will come down to 20%, and 80% you will be investing your time into creativity. That means that will give you a robust product which will be cost efficient, also which will have all the qualities which a customer needs. So this is the comparison between traditional approach and KBE approach. So I'm just giving you an example. So this is an image captured from some of the websites on Google. I'm just using this for the purpose of clarity. Here you see there is a bumper assembly, and then this is the hood and doors, the roof. So different systems are there in this vehicle. So the team, for example, if it is working on the only on the bumper, so there are so many parts coming into picture. So let me show you. All these things are controlled by a single team. So this will go to a manufacturing plant where the complete vehicle is assembled. Okay, so this is the base, the first and foremost understanding. That means a single team is going to work on all these parts. So there are so many parts on this. So there is this is a different part, and there is this chrome strip. This is different part. There is a grill, different part. There is a bumper skin. This is different parts. There is another grill, which is different part. This is a fog lamp ring, which is different part. This is another part. So there are so many parts. So there is one bracket coming over here, which is not visible, which interfaces with the fender and the bumper. So there is an interface between the headlamp here and the bumper. So there will be some sections which you need to consider. So when I start the modeling approach on the complete bumper assembly, what I'm going to do is the first and foremost step. When I get this complete styling, I'll be creating a section, Y0 section, where I will decide on what should be the clearance, how the parting line is derived, what are the manufacturing processes used for each part, gap and flushness conditions between the different parts of the vehicle. Depending on that, I will generate what are the inputs required to create each part. For example, if I'm creating this top part bumper, so this is the grill and this is the part. So I have to create the interfaces in such a way that the parting line and the first flange. So for example, if this is the part which I am talking about, this is the hood. So I'm talking about this part, and then there is a grill here which is coming. Okay, and then there is this decorative strip which will come here, and then there is a bumper which comes here. Please forgive my sketching skills, because with the help of mouse I'm trying to create as much as possible. So this is the grill itself. This is the black grill I'm talking about. So What happens is when I start creating the template, first I will create this part. This is not related to my part, but I'll be taking the input from this part. So this part will have an input of the first flange. So this is called a first flange from this part, from the bonnet. So I'll take this input. I will create the parting line and the first flange of my part, which is this the top bezel of this is the part I'm talking about. So I'm talking about this part. So this will have the first flange, and again this is also a first flange. Again, this is created based on the master sections, like what should be the clearance between these parts. As an input for this part, I will have this as a first flange, and then I will create this part based on the tooling recommendation. What is the tooling direction, where the parting line is coming, here where the parting line is coming, and I'll be creating the next first flange on the grill, which is this one. So that is also created using this first flange, and the whole part is modeled. This is another first flange which is created for the grill, and this first flange is used as an input for this chrome part, which is this one, the chrome strip. And then this chrome strip is developed, and this will have another flange which I'll be using to create the lower grill and the bumper skin. And also this is all about the parting lines and the flanges used to create each other part. In this case, if there is a change, if there is, for example, if there is this split line, whatever it is, if it gets changed to somewhere here, I automatically my part, the most part will get updated. And then if this part gets updated, this grill also gets updated. If this grill gets updated, if there is a change in the interface, then the chrome strip will also get updated, like this, so on and so forth. So these relationships, these parting lines are linked using in CATIA, we have this publication geometry, which we use to create links between these two parts. This is something like a parting line. Now going forward with the attachments. So if there are two snaps and the snaps are getting hooked into different part. So if, for example, if I have a snap here, and if I want to use this snap into this part, so the person who is working on this part will create the snap, as well as he will create the interfacing geometry, which will go on to this part. So when he designs this part as an input, that whatever the snap he has created and the interfacing geometry, what he has created, will go to the person who is working on this part. He will take that and he will update the part. So as and when there is a change on this part, the message goes to this person who is working on this part, and that's how the changes will propagate into each other's parts, and the complete product is maintained. So in this kind of a knowledge based engineering, what happens is individually will have a responsibility on their own part with the interface on different parts, and then all these inputs are taken and then clubbed together and created a complete bumper skin, which you can see here. So this is the usual approach. This will be applied on all other domains as well. For example, instrument panel, floor console, the bonnet, the door inner panel, all these things. The complete vehicle will be designed based on these knowledge-based engineering, so that as and when there is any change, the changes will propagate into every part, and then with very less errors, the whole product design is completed with very less time. So whenever you go for any tests or CAD test in any companies. So the main thing, which if I'm a manager, or if I'm a lead, if I'm asked to interview someone as far as his CAD skills are concerned, I will see his approach, how he's approaching towards the designing of the parts. rather than whether he has completed the design or not. And the approach will mainly involve these kind of techniques. How are you creating the part linkage between different parts in an assembly, and how easily the whole part design can be modifiable? That is what I'm going to see in the design. So this is the typical example which I was talking about. When we go to typical job profile for KB engineers, you will be given a job mainly on creating the templates. So templates are nothing but each individual part capturing all these design guidelines. So you should know what kind of inputs are needed, how the outputs are created, how the processors are created. So when the KBE comes into picture, one more thing which I forgot to mention about is the process. How the KBE process is split into different phases. So the mainly the input program definition, where you will receive a surface from the studio. That surface will have no joineries or nothing. Like you will have to decide how and where the parts are split into different parts, and that is going to be used as a output from CDD. And functional setup and sizing. So during our training, KB detailed training, I'll be teaching you about how the inputs are derived, CDD, like the studio release surfaces, for creating the each part, how the first flanges are created, how the parting line is created between considering the tooling aspect, and how the parting line is considered to derive the gap between the two parts. All these things will come into picture in functional setup and sizing, geometry and interface definition. That is where we do the complete detailed design of the each templates. That will be converted into output part, which will be used for conveying to different teams as well as for suppliers, because that is what will be used for the final manufacturing process. So these are typical job profile of KB engineers these days. You will also be some, I've seen KB engineers working in packaging, advanced concept engineering also. Additional responsibilities include dictating architecture and construction techniques, creating master section development, packaging requirement sections, defining master template, modeling structures. Yeah, these are some of the job profiles which usually a typical KB engineer will be required to do. The engineers with the certified KBE course will have an upper hand in every interview and getting shortlisted, mainly because why I'm saying is, as the complete product development cycle is getting compressed as we go on day by day, because of the changing perception of the customers, because what we see today may not be liked by the customer in next few months or few years. So hence the organizations are coming up with the shortened product development processes to make the products come into market as fast as possible. So because of that, every organization is trying to implement and adopt the KBE methodology in their product development process. Hence, if you are well aware of the KBE processes, what kind of modeling techniques you need to use, how you can use the modeling without using any B reps, that I'll be talking about during the software training part of it. So definitely the KB engineers will have an upper hand. Also, the KB engineers will go on to become subject matter experts in the specific domain, like interiors or the door systems or the bumper skins or closures or BIW, depending on the kind of knowledge you accumulate, especially like what kind of inputs are needed, how the manufacturing process is considered, how the supplier guidelines are incorporated in the designs and things like that. KB engineers with experience of up to 3 years will have opportunities of working for OEMs and tier one suppliers as design engineers, and 3 to 5 years will have opportunities working for OEMs and tier one suppliers as senior design engineers. As I told you, KB is the fastest way to grow as subject matter experts.